Benzene and its derivatives. Aromatic compound, also known as ARENE, is an organic compound that contains at least one benzene ring or other ring structure that resembles benzene in its chemical properties. The criteria for aromaticity are cyclic, all carbon-carbon bond in cycle, planar, all the atoms are arranged on a plane, completely conjugated means delocalized electron in compounds, means the electrons are moving, with alternating single and multiple bonds. Finally, number of pi electrons must satisfy Huckel's rules. So 4n plus 2 equal to the number of pi electron in the compound, and the n value must be integer. This benzene ring is cyclic, all carbon are in cyclic, planar, all the atoms are on a plane, completely conjugated, this double bond alternate with single bond, and then double bond, single bond, double bond, single bond, that is completely conjugated. Finally, the Huckel's rule, 4n plus 2 equal to 6 pi electrons. So we have to calculate the total number of pi electron. 2 electrons here because it has one pi bond. One pi bond consists of 2 electrons. So 3 pi bonds in total, 6 pi electron. Benzene ring, 6 pi electron. Huckel's rule, 4n plus 2 equal to 6. So 4n plus 2 equal to how many pi electron in the compound, and then n equals to 1. So our n value is integer. So this compound satisfies Huckel's rules. It must be integer. So we can say that this compound is aromatic compound. Next, we look at this structure. Cyclobutadiene, it is encyclic, check, planar, check, all carbon and hydrogen, all atoms are on a plane, and then completely conjugated, double bond, single bond, double bond, single bond, check, and Huckel's rule. So count the number of pi electron, 4 pi electrons. 4 pi electrons, so 4n plus 2 equal to 4, n equals 1 over 2. So this is not integer. This cyclobutadiene is not aromatic compound. That's how you check whether the compound is aromatic or not. You have to check each of this 1, 2, 3, 4 cyclic, planar, completely conjugated, and it must satisfy the Huckel's rule. When it satisfies all 4, then you can say that it is aromatic. Since this cyclobutadiene does not satisfy the Huckel's rule, so this cyclobutadiene is not aromatic compound. KEKULE'S structure. KEKULE suggested that the structure of benzene is a resonance hybrid of the two KEKULE structure. So these are the resonance hybrid. It can be drawn like this or like this. It means that the pi bonds, there are 3 pi bonds in this benzene ring. The pi bonds keep changing its position simultaneously. So initially, these are the place of the pi bond, and it keeps changing its position to here. This pi bond changed the position to here. This pi bond changed its position to here. And these 3 pi bond changed its position simultaneously, okay, at the same time. And it can also be drawn like this or like this. So this is what we call resonance structure. The electrons in the pi bond are delocalized around the ring. The circle represents the 6 pi electron. So this circle represents 6 pi electron distributed over the 6 atoms of the ring. So there are 6 carbon atoms. So these 6 pi electron distributed around or over the 6 carbon atom in the ring. Means it is delocalized, or it keeps moving. Because each pi bond has 2 electrons, so benzene ring has 6 pi electron, because benzene ring has 3 pi bonds, so 6 pi electrons. Nomenclature of benzene and its derivatives. There are monosubstituted benzene, disubstituted benzene, trisubstituted benzene, and more than 3 substitution, 4 or above. Monosubstituted means 1 substituent at the benzene ring. Di means 2 substituents at the benzene ring. Tri means 3 substituents at the benzene ring. So for monosubstituted benzene, we name the substituent and add the word benzene. So here fluorine attached to the benzene, the name is fluorobenzene. Nitro attached to benzene, nitrobenzene, and here ethyl attached to the benzene, we name it as ethylbenzene. That's how you name the monosubstituted benzene. For common and IUPAC name for benzene, so here the IUPAC name for this compound is methylbenzene because 1 methyl substituent and the parent is benzene. And then the common name for methylbenzene is toluene. Next, IUPAC name hydroxybenzene. The common name is phenol. Hydroxybenzene means hydroxyl group attached to the benzene ring as the parent, hydroxyl as the substituent, so it's hydroxybenzene. This is the IUPAC name, and the common name is phenol. Aminobenzene, IUPAC name because amino group attached to the benzene ring as the parent, and the common name is aniline. Next, carboxylic acid substituent attached to the benzene ring, we call it benzoic acid. Aldehyde group attached to benzene ring, we call it benzaldehyde. Ketone attached to the benzene ring, acetophenone. So for you to call it acetophenone, make sure the carbon that is attached to the benzene ring, that carbon has the double bond O, not this carbon. The carbon that is attached to the benzene ring has the double bond O, then you can call it acetophenone with the total number of carbon substituent 2. Then you can call it acetophenone. Disubstituted benzene. Relative position of substituents are indicated by prefixes ortho, meta, and para with the symbol O for ortho, M for meta, and P for para, or by the use of the number. Here, benzene ring as the parent, 2 substituents bromo at carbon 1 and carbon 2. The IUPAC name is 1,2-dibromobenzene, or you can call it ortho-dibromobenzene. Ortho means the position of the substituent is at 1 and at carbon 2. That's what ortho means. And if the substituent position at carbon 1 and carbon 3, we call it 1,3-dibromobenzene, or you can call it meta. Meta means the substituent at carbon 1 and carbon 3. Next, substituent at carbon 1 and carbon 4, you call it para. So para-dibromobenzene for this compound. Next, disubstituted benzene for different substituent. Here, for same substituent, all bromo, same substituent. But here, disubstituted, but different substituent. Alphabetize the name of substituent preceding the word benzene. We have chloro and bromo, so you put this bromo at carbon 1 because it is B and then C. B first and then followed by C. So that's why this carbon will get carbon 1 and this carbon will get carbon 2. Because B first and then C, so the name of this is 1-bromo-2-chlorobenzene, or you call it ortho-bromo-chlorobenzene. Chloro, nitro substituent. This carbon will get carbon number 1 because this is C and this is N. So C first and then N. Alphabetize the name. So carbon 1 is at chloro, carbon 3 at nitro. So you name this compound as 1-chloro-3-nitrobenzene, or metachloronitrobenzene. Meta means carbon 1 and carbon 3. Next, for this one, it is carboxylic acid and NO2. So here, this carboxylic acid with benzene ring can be the parent. So you don't call it parent benzene anymore. It is benzoic acid as the parent. When benzoic acid as the parent, automatically this carbon will be carbon number 1 and nitro will be carbon number 2. So the name of this is 2-nitrobenzoic acid or ortho-nitrobenzoic acid, because ortho means carbon 1 and carbon 2. And here the parent is not benzene anymore, the parent is toluene. So benzene ring with 1 methyl, you call it toluene. When toluene become the parent, automatically this carbon will be carbon number 1 and this will be carbon number 3. So the name of this compound is 3-chlorotoluene or metachlorotoluene. Meta means at carbon 1 and carbon 3. When two substituents attached to a benzene ring are different, like these two different, but here halogen and nitro, but here different, the parent name of the compound is determined by the highest priority functional group. So this is the table, priority table. Carbon atom bearing the substituent that define the new parent will be at carbon 1. Increasing priority. So the highest priority is carboxylic acid, and then followed by ester, aldehyde, ketones, alcohol, amine, alkenes, or halides. Here you are comparing between alcohol and amine. So alcohol and amine, if you look at this table, alcohol has higher priority than amine. So alcohol will be the parent. So you name this as phenol, not aniline. Because if amine is parent, you call it aniline. But now, alcohol has higher priority, so alcohol will be the parent. So the parent name is phenol. And then, when the alcohol becomes a parent, the carbon that is attached to the hydroxyl group will be carbon number 1. So automatically this amino group will be carbon number 4. So 4-aminophenol. For this compound, the substituents are amino and halogen. So here, if you look at the priority table, the group for increasing priority, amine is higher than halides. So amine will be the parent. So you call it as aniline. Benzene with amino as a parent, the name is aniline. And then this will be carbon number 1, this will be carbon number 4. You call it 4-chloroaniline or para-chloroaniline. For TRISUBSTITUTED and more substituent, assign the lowest set of numbers and in alphabetical order for the substituent. Same as like in alkene. So parent should be determined by functional group priority. Here, 1, 2, 4. Okay, 1, 2, 4. Or it can also be 1, 2. If you put here number 1, here number 2, this will be number 5. So you have to put this number 1, number 2, and number 4. Lowest set of number. We don't want 1, 2, 5. We want 1, 2, 4, lower. So the name of this is 1,2,4-tribromobenzene. Here we have halogen, alkyl group, so the parent name will be benzene. And then 1, 2, 4 as well. We don't want 1, 2, 5. So we want 1, 2, 4, lower set of number. So 1, 2, 4. So the name will be 4-chloro-1-ethyl-2-propylbenzene. And here, alcohol, nitro. So nitro and alcohol will be the parent. So this is phenol with this automatically carbon 1. And if this carbon number 1, this will be carbon 2. 1, 2, 4. We don't want to count anti-clockwise. If you count anti-clockwise, this will be number 1. And this will be number 4, 5, 6. 1, 5, 6. We don't want 1, 5, 6. We want 1, 2, 4. Lowest set of number. So the nitro will get number 2 and number 4. So the name of this is 2,4-dinitrophenol. Next, if the benzene as the substituent, we call it phenyl. When the benzene becomes substituent, you don't call it benzene, you call it as phenyl. And if the benzene with 1 methyl becomes a substituent, you call it benzyl. Okay, means as other parent here, this become phenyl. And other parents here with benzene and methyl as substituent, you call it benzyl. If alkyl substituent has larger than the ring more than 6 carbon, compound name as phenyl substituted alkene. So this benzene will be the substituent if the straight chain carbon is more than 6 carbon, because benzene in total 6 carbon. If the straight chain carbon is 7 and above, the straight chain carbon will be the parent and the benzene will be the substituent. If the benzene becomes substituent, you call it as phenyl. If the chain is unsaturated, have carbon-carbon double bond or carbon-carbon triple bond, or contains important functional group, the benzene ring is considered as phenyl substituent as well. So here, this straight chain carbon has less than 6 carbon in total. Less than 6 carbon in total, but it has functional group carbon-carbon double bond. So if the straight chain has functional group, it will become the parent and benzene will become the substituent. So here you give the number to the straight chain because this is parent, 1, 2, 3, 4. So the name of the parent is 2-butene because carbon double bond at carbon number 2, and then phenyl will attach to carbon number 1. This phenyl, benzene ring as substituent, you call it phenyl. So you have to count from the left, not from the right. If you count from the right, this carbon will be carbon number 2, but the phenyl position is at carbon 4. We don't want that. We want the lowest number. So this carbon has to be carbon number 1. Next, 2 carbon straight chain with alcohol group. This will be the parent. So the name is ethanol. The ethanol, this OH attached to carbon number 1 because we want the parent carbon at carbon 1, functional group at lowest number of carbon. So the benzene attached to carbon number 2, the name is 2-phenyl ethanol.